So here we have a triangle, a right triangle, and we want to solve the right triangle, which means find any of the missing sides or angles. So it looks like it tells us A equals 3 and C equals 9. We could find the missing side with the Pythagorean theorem, a squared, which is 3 squared, plus b squared equals c squared, which is 9 squared. So b squared is going to equal 81 minus 9, and that is 72. So b will equal the square root of 72, and I'm going to simplify that a little bit. 9 times 8 is 72. That's the first thing I saw. So that'll simplify. Square root of the 9 comes out in front as a 3, and the 8's still under. But 8 has a perfect square in it as well of 4. So I'm going to square root the 4, comes out in front as a 2, gets multiplied to what's out there, and leaves us the 2 still under. So b equals 6 square roots of 2. And now, how do we find the angle? Well, if I look to find angle A, I'm going to find a trig function that relates that angle to the two sides I was given, which were 3 and 9, and that looks like that's going to be opposite and hypotenuse. So the sine of angle A is going to equal opposite over hypotenuse, and that simplifies to 1/3. Now we're supposed to find these, I didn't put it on the slide here, but they're supposed to find these in degrees. So how do I find the angle whose sine is 1/3? I get out my calculator and I see that I'm in radians, so I'm going to hit the mode and change it to degrees. And then I'm going to put in inverse sine of 1 divided by 3. And that will give me the angle. I'm going to round that to 2 decimal places. So A is approximately 19.47 degrees. Now, if I need to find B, well, we know that in a right triangle that the two acute angles are complementary. They have to add up to 90. So I could just take 90 and I can subtract the answer that's in my calculator, and that will give me the other angle, which is 70.53 degrees.